welcome everyone to one of the many Fireside chat series and webinars we're going to have as a part of this forum. My name is Sahil Potnis. I'll be the moderator of this session today. So, just as an introduction, before we get into a very fascinating discussion here with Chenji and Kuchan, a little bit about digital divide data, about myself, where I come from, a few introductions we can get out of that way, and talk about interesting things a few minutes after that. Again, my name is Sahil, part of the Digital Divide Data team. We are a New York-based a global enterprise that provides data services across in the value chain and with the industries like automotive, autonomy, especially given the context of this particular topic, defense, legal, content services, and many more beyond what I just mentioned. I've been in the autonomous vehicle space for almost last 1 decade, and I'm here to talk to Chenji and Huchan about the machine learning, data strategy for autonomous vehicles, especially. So we'll get into that just a second. If you're wondering who should be joining these fireside chats and webinars, if you're anywhere in the industry working on the autonomy problem, autonomous systems, or automotive, or anywhere in the ecosystem up and down of these problems, be it a tooling, a platform, if you're a research and development fellow or a student, these are all great sessions to be a part of to understand our collective industry experience and knowledge. And the goal of these sessions is straightforward, right? We want to make it interactive, engaging, and share our knowledge, evangelize the experiences that we've had, and most importantly, to make sure we are promoting, the technology and the future of, the autonomy overall. So with that being said, I'm gonna please request my fellow speakers, Chenji to start with, and then Kuchan to introduce yourself, your role at your companies, and kick it off.
Yeah, thanks, Sahil. Hi, everyone from all over the world. My name is Chenji. I'm the tracking team lead at Motional. Tracking is part of the autonomy pipeline, which covers a big part of how we make decision in our robot taxi platform. I've been in the industry for about more than 8 years now. I've been with Motional, who is specialized in working on the L4 level robot taxi service for over 4.5 years. At Motional, I'm tracking team. Tracking team is specialized in improving the spatial and temporal consistency of the entire perceptions output. We perform various tasks, including data associations, data estimation, as well as low-level sensor fusion for the entire perception stack on our robot taxi. Before Motional, I was in Uber ATG, which is now Aurora. I've been with Uber ATG for more than 3 years, almost 4 years. Back there, I worked across various kind of field, including the mapping. I started in the mapping team, working on perception prior, then moved on to perception team, worked on VRU tracking, highway detection, nighttime detection, all kinds of special projects. Yeah, that's a little bit about me. Yeah, nice meeting you guys.
Thanks, Chenji.
Thanks, Sahil. Thanks, Chenji. First of all, I really want to thank you, Sahil, for having me. It's a great pleasure to reconnect with my former amazing colleagues and being in the part of this discussion today. So a little bit about myself. I can call myself a roboticist. I love robots, and my journey starts from going to the undergrad school as a robotics undergrad school, and completed my graduate studies at the Ohio State, working on mostly mobile robotics. The lab that I work at Ohio State also was one of the attendees of the DARPA Urban Challenge and DARPA Grand Challenge, which I got multiple exposures of the different stacks of mobile robotics, especially autonomous driving. And I spent 7 years in Motional with these amazing guys, wear different hats as a IC team lead for the perception teams, and also director of the perception and planning, perception and prediction for the ML systems. So I see also how things change from what we call classic and geometric robotics to the more machine learning first, data-driven first approach. So currently, I work as a research engineer at Helm AI, mostly working on the large foundational models for the perception tasks. Yeah, it's great to be here.
Awesome, awesome. One of the reasons we got Buchon and Chenji on this panel was because of the depth and the diversity these guys bring with their experience. I worked with Chenji back at ADG, and then with both of them at Motional. So it's been very rewarding to work with such smart colleagues, and having them here on the panel is only gonna get your experience understanding this problem a little bit more better. So we'll dive in. Given the time we have, I want to make sure we maximize the question answer response that way. So the format of this session is going to be like a fireside chat. So we'll essentially have a discussion between the three of us. We'll ignore for a second. We are on a webinar and we have a bunch of attendees who are here. Towards the end of the webinar or the fireside chat, I would like to call. We'll take questions. So please note down your questions, or you can even submit them on Q&A as we talk. And then towards the end of it, we'll take questions one by one. All right. So the first topic of interest, right? We have heard about when it comes to a machine learning system, it's all about data, right? It's about more data you feed, better the system gets. More diverse data you feed, better your performance, and so on. We recently have been looking at some of the Gen AI, competition across the world, and claims about cost and size of the LLMs and so on and so forth. So if you had to apply a similar sort of a problem, Chenji, I'm going to start with you first. What do you look at when it comes to diversity of good data for training your model? What are some of the parameters you would look for in a good data set?
A great question. So I will talk about what I look for and talk about how you can get that estimate later on. So what I always look for is think about your ODD and your future. ODD stands for Operation Design Domain, I think.
Yeah.
Think about your ODDs and think about future ODDs. You want to diversify in terms of spatial and also temporally. I think just based on my experience, right? So different companies have different goals for sure, especially for robotaxi service. But you cannot you don't want to roll out your let's say product only at the middle of the night to operate, right? You also want to expand your footprint to different cities, but there will be a big difference based on my observation in the past. I worked on data set across, I guess, Arizona, California, Pennsylvania, as well as Singapore, as well as Korea, all over the world. They're different, right? There's like snow piles on the ground for Pittsburgh data you need to handle. There's also like very flat ground, boring kind of suburban area in Arizona you want to handle as well. So these are I think the factors you need to consider, which means as a ML engineer, right, you want to stay really close to your testing and operation team. They're actually a critical piece to help you to get you the critical data that solve this puzzle. That's my high-level opinion. Yeah.
Got it. So diversity in terms of your interactions, the time in which you're collecting different operational design domain, ODD elements that you have, makes sense. But from your point of view, has this been your experience as well, or what different?
Definitely I echo Chenji's points, and maybe in general, any ML models, like distribution is very critical, right? So we always talk about the out of distribution of the model being out of distribution. Maybe this is going to be abbreviation riddle, but don't let your ODD, operation defined domain, to be OOD, out of the distribution, right? The models like obviously there are generative models, but even those models are having in the distribution. In order to get those distribution nodes, they are synthesizing the small pieces and generating something new from those small pieces of synthesized, let's say, the words, right? Especially in AV, I think this is really, really important. For LLMs, like embarrassing mistakes maybe can give you, like the ChatGPT can give you an embarrassing answer, but for the AV, this is safety critical, right? Someone in the car. So in understanding this, ODD and also your distribution become critical, and then what are the levers? Mentioned the spatio-temporal, right? This is one of the obvious ones. Chenji mentioned some of the things related to being in different cities, or like the being in different, like the environments, the weather conditions. So understanding these data, like the domains, is very critical. And also like how to handle this. I think there are a couple of methods to doing this. It's just how to see the distribution, right? There are classical methods and also like very advanced methods to handling those, clustering in the sense of the embeddings, what people call like the essence of the data, right? So because you want to have sometimes very large of data, but you also don't want to overfit to that data. You want to keep the distribution and get away from the overfitting. So there are a couple of methods that people are using to make sure the diversity is there and distribution is well handled.
It's an interesting problem because, in my experience, when you have, you have the 90% of the problem and then you have the 10% of the problem, right? 90% of the problem is essentially the normalized distribution of your exposure in the ODD, and the 10% is the edge cases, or 5% is the edge cases that you have, which is you won't find, you won't find, for example, a baby stroller in the middle of the road. But what if you find it? What if you have it in the middle of the night? Is your model smart enough to understand, interpret that data? So speaking about that, Guchan, can you talk a little bit about the role of synthetic data in the world of training? Sort of traditionally speaking, it's always been the raw sensor data from the platform on which you're working that takes the precedence in training your models. How is the synthetic crowdsourced data from all the different sources helps you in terms of training, plus some comments on the velocity of the work, because you can get more data in a short period of time?
Sure. I maybe build it up on the example that you mentioned, the stroller on the road, right? So for the synthetic data, I think there are two important, like the pros that you try to bridge the gap. One, it's, as you mentioned, the solving the corner cases, especially those rare, like what we call corner cases, is all rare occurrences. Let's call it that way. So in order to get that rare occurrences, your cost of manually collecting data and annotation goes exponentially, because in order to have just like that simple like that instances of the rare cases, you need to collect even more data, so that goes exponentially high. So that's the biggest cost for you to get those rare cases. Synthetic data generation definitely helps on this. I'm going to talk about that. And also the second part I will mention, it's the anybody who works on the ML systems, who created some ML models and trained them, knows how important is the augmentation is, how powerful tool is. I think synthetic data generation, having the synthetic data, it's bridging the gap between creating these corner cases or the rare cases, instead of try to manually go and collect this exponential cost, and also have this very powerful tool of the augmentation. I think that's the main lever for the synthetic data. Obviously, it helps to like the bootstrap.
John, I was going to ask you, can you tell us a little bit about data augmentation? What do you mean by that?
So like synthetic data generation, basically you can, let's say you can, what is called in paint, or change the environment. So like you can have you can start saying that it's a sunny day and now it's like the raining day, but also you can have some blur in the data, right? So like some defects, you can start to learn these defects with the power of the generative AI, with the maybe very large models. And then this will help you to model to not just to overfit, going back to the previous discussion, not to just overfit the data, but start to see these augmentations and adapt those.
I see. No, that makes sense. So in terms of like just connecting the picture together, right? Like from the point of starting the data collection to actually, or not data collection, even just data curation, it could be from, from the synthetic data, from the data you collected from your sensors, all the way to seeing your performance improvements, right? Or whatever your target model improvements are. It's a very long process, right? And Chenji, we have done this sort of work together in our previous experiences where When I used to report on the performance analysis of the data, I would be like, oh, this is only a 2% change of this particular failure mode, while you were expecting a 15-20% change, and that didn't match. Or it could be the other way around. The other way around is more surprisingly, pleasing than the first one. But what anchor points do you keep in your planning, or maybe even execution process, from your initial data problem to performance problem? What is your guidance for the teams to manage that end-to-end pipeline?
Sir, can you clarify your question? What do you mean by the anchor point?
Like, what would be the things which you will recommend folks in the same space to watch for, right? Like, you don't want to spend too much time in doing collecting a data or training a model one way and then not getting a result at the end. What would be some of the guardrails that you recommend to keep on the way so we don't kind of are on the path of high probability of success at the end?
Yeah, there are definitely different ways to do that. I think we just talked about using synthetic data. That's the way to speed up this kind of a data collection and improvement loop. There's also, Motional had also publicized our continuous learning framework, which is another way you can speed up this iteration. So you can mine those highly impactful error cases directly from your previous training dataset and upsample them or add them into your training distribution. That can greatly speed up your higher training. We can also use semi-supervised learning, which is also something I experienced in the past. That gives you really good kind of cost to kind of impact kind of a ratio, right? Because as we all know, human annotation most of the time is quite expensive. But semi-supervised learning, which means that you bootstrap by a very strong, powerful kind of auto labeler, so you can get a big batch of cheap data to work on. Depending on how much you can afford, you can also try that and make sure it does not skew the distribution too much. But from my personal experience, I think maybe 1-10 kind of a ratio between human and semi auto label is the right balance you can strike. Yeah, that's high level advice I have. Yeah, how to make this quicker iteration. Yeah.
Right. Kuchan, anything you want to add to that? Like, just performance.
Definitely. Even I do unsupervised learning or some topics of the synthetic data generation. I also maybe a little bit traditional when it comes to the testing and validation. I believe there is no shortcuts on that in usually. And the way that I'm thinking, it's, as you know, the testing and validation, probably it's a smaller data set compared to the training. These methods on the testing and validation does not rapidly improve as opposed to the ML models. You see the different models every day, the different change of the data generation. This is kind of cumulative approach that you're building, your testing and validation, and that stays there almost forever. So even the new models are using very old techniques or maybe this similar benchmarks. This is very cumulative in the industry and also in academia everywhere. And to the changes point as well, I really think that adding synthetic data and also the simulations accelerate this. But I feel this acceleration, it's not. That's not as significant compared to what we are seeing, the improvements in the ML models. So I also see this testing and validation as a kind of building infrastructure, right? In order to train a model, you need to have a good infrastructure, and big companies have built their infrastructure over time. Testing validation is kind of like that for me. It goes from the first principles, but yeah, definitely for the synthetic data generation and also simulations helps this a lot.
I think I have another quick point.
Yeah,
Gushang made a really great high-level summary about why do we need a synthetic data. I can give some low-level tactic ones, but I've been in the tracking space for a while. So one challenging problem in tracking is occlusion handling, right? So how do you track, let's say, actors or agents on the road when they go goes dark,
Yeah.
it will be impossible to actually get human annotation on those because it's counterfactual. You can see them most of the time.
Right.
Human annotation relies on sensor input. There's one way to do that is you use synthetic data that gives you sort of like free labeling, especially for those counterfactual cases. And now you can even train your system to start anticipate or hallucinate agent actor before they even appear at those critical kind of locations, which may affect your AV performance.
Right.
So that's another tactical way of using synthetic data to solve specific edge case problems.
Yeah, I remember a very specific, sort of, not going to use the abbreviation. That's an IP from our previous companies, but we had a situation where there was a VRU child running in front of a bus. After the bus stopped, and they got down, they crossed in front of the bus, right? So for the traffic coming to the left of the bus, it was basically a completely occluded VRU, right? And they had to brake hard, to make sure they don't hit it. So I think all of these corner cases, edge cases, they're perfect candidates for synthetic data. Even at DDD, we are trying our best to increase the amount of effort and investment we're doing with building synthetic data sets, because at the end of the day, you want to diversify the amount of data you can provide with the human output, but at the same time, you also want to make sure we have a lot of synthetic data sets ready for key players in the market to commercialize and to use that in your development for accelerating the go-to-market timelines. So very good. So speaking about just kind of moving the gear here a little bit, we mentioned the unsupervised and supervised learning a couple of times in our last 15-20 minutes of talk. Guchon, I'm going to ask you as someone working in that space or who has also worked in the supervised learning space before. What is the difference? Like if there was a layman sort of definition of these two terms, like the end-to-end algorithms, unsupervised, like can you give us a little bit of definitions from your perspective?
For sure. So like maybe just from the simple terms, right? Unsupervised learning, it's learning algorithms that basically doesn't require explicit data annotation. The reason that I'm saying explicit, I'm going to explain that later on. And this mainly goes back to most of the traditional ML clustering algorithms. Maybe we learned like k-means, BCA, like the hierarchical clustering, GMMs, and some new deep learning ones as well. So like maybe you heard like autoencoders, variational autoencoders, some parts of the diffusion networks as well. I think the main confusion comes from the indication of unsupervised versus self-supervised, because self-supervised is sometimes under the category of the unsupervised learning. One example is GPT. It's trained in significant data of the self-supervised. Sometimes, again, this is under the category of the unsupervised by predicting the next word, right? They are not giving any specific instructions or human in the loop, but the GPT is trying to predict the next word. And this is kind of self-supervised and unsupervised, right? And these are similar things are happening in the diffusion or variational encoder networks in the vision area. So you're giving the picture to the model, and model it's trying to blur the image and to reconstruct the image back without giving any explicit data annotations. So what this helps networks, it's to generate going back to the previous discussion, the embeddings, like understanding of the the descriptors of the word, sentences, or also the image. So you will have large amount of the data going through these big models, and this is gonna learn to the essence of the data. And these are usually connected with some of the tasks where you have the supervised fine-tuning at the end. So I hope this explains what it means on the supervised and supervised. Again, most of the times we see it. Mm-hmm.
Does a good job. Like if I had to abstract it out, it's basically unsupervised learning. You do not have any intervention or human in the loop. Data goes in, it sequentially goes through your units of model, and then you have an output, which in a lot of times gets the supervision towards the end of it, but there is some check and balance in the process, but not towards the beginning when it comes to bigger volume of data. Chenji and Guchan, maybe either one of you, Is there any difference when it comes to deploying a supervised or unsupervised model on the platform? Does it make any change with respect to the size of the model, the latency of the system, or it doesn't matter? It's just the way we train one way or the other?
Yeah, I think it's maybe a little bit similar to synthetic and the human label pieces as well. This discussion,
Yeah.
because you can deploy enormous amount of the data with unsupervised learning, and then your like backbones or the main feature extractors can learn very diverse of the data. So that really like to bootstrap your capability of the model. So this piece is the main importance in the supervised learning to scalability, just having increase the capability of the model, because you have like big models as well usually on those. Capability increase and the scalability increases. That's the main power of it.
Yeah, I want to add to Bhushan is that I don't think that in terms of deployment, there's not that much difference. Typically, what we use unsupervised or self-supervised is to train a good feature extractor at the back end, which then the downstream part will be thrown away, and then you will be connected to another one that's trained a supervised, fine-tuned unsupervised data. And the typical different way to do that, depending on the task, you can do like mask autoencoder type of unsupervised learning. If any more nowadays, because the success of I think GPT type of model or BERT, those type of model, any task, if you can, it can be framed as a sequence learning problem. You can do the similar way, like mask out after tokens in the sequence and force the network to predict, learn. It applies to like machine learning based tracking, motion forecasting as well. So yeah, so that's what I would suggest. Another thing I want to point out, add to this is, because of the uniqueness of our application, right? It's like a self-driving car, so and motion planning is a big part of it. I've seen people doing the purely reinforcement learning to train motion planner, which is, you can consider that as another way of doing unsupervised learning, which depends on like a reasonable simulation environment. Then you can just let the planner to train by itself. Don't collide with anything. Don't do curb strike. Don't do dangerous maneuvering. And then it can be trained in an unsupervised way.
Got it. Well, that's very interesting. We can go more into the cost optimizations and what are the best practices. Not the topic here though, so I'll get us back on the machine learning data part of things. There's a lot of talk about automated labeling, automated annotations, semi-automated annotations, human in the loop for verification of those automations, or pre-labels. There's a lot of jargons going around in that space. So Chenji, maybe starting with you, what do you think is the right balance between, I think you mentioned some proportions before, but how do you see this landscape evolving over a period of time? For someone like Digital Divide Data, we are in the services and we want to make sure we offer all the different options, not just human labeled data, human labeled or human augmented data as well. Where is this landscape going, and how in your experience it's going to change over the time?
Yeah, totally. I think the goal never changed, right? Everyone wants cheaper data annotation and quicker data annotation. So in terms of this auto labeling, I do see that the technology evolved significantly when I was working on that. So when we started a long time ago, you can imagine the original version of auto label is just very strong, powerful kind of a perception and prediction kind of system offline. Because it's non-causal, right? Since it's run offline, you can get future input as well. So you can utilize as much information as you need to make it to work and give you high quality kind of auto labels. Nowadays, that things evolved into those big kind of a VLM video/visual language models that gives you high quality annotations typically from images quickly. They're very powerful, easy to adapt to what we need, and can find those out of distribution cases easily as well. So these are the, I think, the evolution I'm seeing. But the goal doesn't change, right? We just want a quicker and cheaper annotation in the industry. Yeah.
Interesting. Kuchon, do you have any thoughts to share on this automation piece of labeling?
Yeah, I think in terms of testing and validation, we definitely use really high quality human label data. We cannot cut the corners over there, and it's going to be there. And plus for fine tuning, right? Even if you have a lot of auto label data to bootstrap, or even unsupervised learning to bootstrap your backbones, you still need to test specifics, like fine tuning human label data to get excellent on that. And yeah, this is the one thing is like from the volume perspective, it's since the models are improving, we have more capable models. We keep adding more data, and then fine tunings doesn't become even smaller. That's also increasing as well. Now you need more human label data, but maybe couple magnitude more auto label data for the bootstrap. I think this needs, it's going to be there, and also as I mentioned, that you improve your validations, that needs to be human labeled. Yeah.
Got it. So safety validation data sets are all hand curated. They need to be top of the line, really good quality data sets. Now, if you talk about the automated labeling, how are we solving for the ground truth problem, right? Because human annotations and the context that the humans have is deep, and I think we can understand it's not just drawing a bounding box or a polygon around an object. You kind of know the history of that, or in the future, or maybe some other elements which are not easy to connect. And maybe with the the GPT sort of models and with the foundational models, this is becoming an easier problem to solve. Is ground truth a problem in automated annotations data sets, or we already have solved for that, most of it?
Yeah, so I think I will say it's not solved. It's just like improving, right? So one of the interesting and fascinating phenomena is your models, like we know how the distillation is, and maybe the people doesn't know, like you just, maybe some of the terms, auto label is part of the distillation. You have very large capable model, you are annotating for you the data, your small model distills from that to those labels it's being used, and small model improves, which can run on the edge like faster. But another interesting phenomenon is these models, like the large models, impact even larger models, and those larger models can get better. So examples of the recent DeepSeek are one, and the way that models improve each other, not the distillation perspective, big to small models, but the big to big models, even more capable models. I think there are always something new it's coming in this industry. I think that's the fascinating part of it. I wouldn't say it's solved. Yeah, I think that's the basic summary.
I agree with you. I think there's more awareness, I would say, of these terms and topics generally now. Changing, if you have to compare 2 to 3 years back, right? I don't think we even give emphasis to as much automated labeling or any of these things. Now with the advancement of OpenAI, and there's a lot of these new companies coming out, there's much more push to do that. And I think the same problem or the same solution can apply to the problem of data mining, right? So I want to talk about data mining, Chenji, with you for a second. Right, we talk about collecting the huge volumes of data or curated data sets, but sometimes it's about finding a needle in the haystack, right? Like you need to know what are the snippets of the data of interest that you're looking for. Right, if you're looking for a VRU interaction on a highway 70 miles per hour, you're not going to get that, right? Once in 100, I don't want to say 100,000, but thousands of miles. How is the problem of data mining being solved? How do we know what to look for in a huge data set?
Yeah, there are two parts actually I'm going to talk about. One is actually how you mine it. The other one is, even before that, you need to figure out what you really, is there a need for you to mine data? So I typically want to start with a good kind of data insight project on anything I worked on, understand what is the distribution in the data set that to begin with. Of course, you will get signal from the road, like for our robot taxi application, you will get signal from the road, right? If it's not cannot handle certain scenario well, there's a road event, safety has kind of hazard event happening, but that signal is getting sparse and sparse, very very sparse. So I don't think that it makes too much sense in current industry that everyone over-index into that kind of a signal. So you as an owner of, let's say, your model component, you definitely want to start by auditing what's actually in the data distribution. Come up with a very full way of kind of stratifying by capability, by scenarios, by all kinds of attributes you can think about. Okay, coming back, once you understand that, you know what is lacking, what is the gap, then figure out a way to mine data. We have, as I mentioned before, we already publicized our continuous learning framework. It's comprised of high quality data miner, which can extract features from the log according to certain criteria that we can specify and find the log we want. A recent improvement or evolution I can see is, as I mentioned slightly earlier, is the BLM model, right? So, which is very powerful, as we saw, giving in like a very minimum kind of a prompting. So it is able to search through your entire data set and find the cases that matches your kind of expectation. Just random example, for example, I want a person walking a dog in the middle of the night on Vegas Street. Can we find that? So yeah, they can, because there's a visual kind of a context there already, which will be very difficult to do by the traditional way. So that's regarding the mining advice I have. Yeah.
Okay. No, makes sense. Awesome. So just doing a quick check on the time. We are 20 minutes out. Got a couple of more discussion topics, and then we can switch to Q&A. So we talked about collection of data. We talked about mining of the data, strategies around it, means to make sure we are going to get a performant model end to end, and so on. Guchon, maybe with you, now all of this being done, right? When it comes to deploying a model, what is your preference / experience in terms of deploying a large model, with a large number of features infrequently, or would you rather prefer incremental improvements with a smaller model deployment? What is easy? I mean, maybe it depends on the company's milestones and the goals, but what is your experience?
Yeah, maybe I'm a little biased over this. As I mentioned, I come from classical robotic approach. We were releasing things all the time, right? There's small changes all the time. But ML models are usually like bottlenecked by the data and the training. So inherently that's slower compared to what traditional software development in terms of the release cycles. But when it comes to, like, I categorize this as two ways, as you mentioned. It really depends. One, if you have a new feature, let's say you want to add the new feature of your autonomous vehicle, I really like to do the frequent releases, because that's how you're gonna get faster. But for the mature feature, the improvements, it's relatively slower compared to releasing new feature. Your incremental changes become saturated, and you only let the data to speak itself. By experience, that's slightly slower.
Got it. Chenji, my gut also says that you're probably going to agree with Guchon, because I think that's probably the right way. But yeah, what are your thoughts on that?
Yeah, I think that makes sense. So I was actually looking at the Q&A again. Are you asking about in terms of large model deployment, right?
Yeah, large models, small model deployments. What is the preference?
It depends on your release. Yes, I know in the industry there are different ways to do that. There's definitely pros and cons, right? Some companies, they do like a synchronized release, meaning that they can be multiple models, but they released all together at the same time point, typically like once or twice every year. And then there's a lot of big effort in terms of testing on that, releasing make sure no regression and finding improvement, things like that. There's a different way to that, asynchronous kind of model release, which is that whenever the model is ready, you have a very kind of robust, rigorous testing framework, so help you to identify if it's going to improve or regress downstream. If everything checks, then you can release your model and work with the downstream customers to improve their model. They can release iteratively. So there's different ways. I don't have a good answer like which one is preferred, but in terms of feature releasing a model, I would say in current ML world, what I see most of the time is do a kitchen sink approach, what we call. It's like group and batch as many features you can think about together, but that can minimize a lot of testing cost. And if everything checks, you can release that. You can do ablation study later on to find which is the biggest.
Right. Well, makes sense. I think this is all fantastic. And just to close out, maybe with a sort of a futuristic, if you all had a sort of a what do you call the magic ball, right? And you had to look into the ball and predict next 5 to 10 years, or maybe just like let's say 5 years from now. Which one maybe starting with you? What are some of the innovations you think are prudent to happen, or what would happen in this space, which will just transform the data-driven development aspect of autonomous systems? AV maybe, or perhaps, but general, what do you think is going to be a key innovation space in this field?
Yeah, I think this is, since it's a data-centric, I think this was the problem in the past. I think it's still, and it's going to be, as we discuss distribution and the balancing of the data, how you're going to manage the data, because that's what the models learn usually. The second, it's as we mentioned, the synthetic data generation and augmentation. I think this is going to be, and we've seen it's accelerated, and it's going to be the main part of most of the models. And we haven't talked about much about data authenticity. Maybe in AV we don't see that often, but there's a huge effort on large language models to make sure there's no harmless data, and the authenticity of the data, it's important. And maybe lastly, it's the multimodal, like the complex data annotation. From the AV space, we know that we have LiDAR sync with the cameras and radars. We are annotating them together, but also having additional the data with the, let's say, the text capabilities. It's important, like the multimodal data annotations. I think these are like the 3 top ones.
Very well said. Chenzi, take us home. What do you think?
Totally agree with Bhushan. I have only a few small points to add. One is in 5 years, I can predict like the sensor cost will be driven down significantly. So which means that if your application is limited by, let's say, a high BOM cost of the sensors, BOM means build-up material, or infeasibility of using getting certain type of information on the road, just rethink about that, right? So we've seen that trend going on, and that's a trend will continue. So that's one thing, which means like easily accessible, high quality on-road data coming up in the future. Totally agree with the large language, VRM, those kind of models, innovations, and the impact. I would say another thing I can predict is we'll see more and more kind of models will relying on like kind of a multi-mode foundational model, and then you can quickly just adapt them to different tasks you need. For example, auto labeling, on-car kind of applications. It can be even adapting to doing both perception, prediction, even altogether, or localization, mapping. Everything can be lumped in, derived from one model. So that's another trend I'm seeing. Yeah.
Got it. No, it's very interesting, and as a company, we are also striving to be experts and thought leaders in this space, so that we can continue to provide world-class solutions to tech companies globally, right? All right, awesome. So we got 10 minutes to go. Quite a lot of questions. I'm gonna go through it one by one and distill, if you may, in the to all of us, right? All right. So the first one we have is, what are some edge cases where the data collected or labeled was not sufficient, or it negatively impacted the performance while you expected? So did we have any inverse performance, like regressions in a way, when we collected the data while expecting a positive performance in your experience? Any one of you?
I think I can come up with a few examples what we mean by the edge cases based on my experience in the past. For example, just like some time back when we operating part of the United States, we found there's a certain area where there's large kind of a skateboarders crowd. So those are the cases which are very hard to kind of handle but in the sense because the skateboarders can quickly transition their kind of motion model, right, in trackers differently, and it sometimes can not very always compliant to traffic laws and even social kind of courtesies. So these are the one typical case for edge case we need to handle. Another case I also hinted in the back is, for example, like a snow pile in Pittsburgh. So because it's winter, it's a certain time of the year when we started operation, let's say in the warm weather, but later on if you want to expand footprint into a cold weather area, these are the challenges you need to face.
Yeah, especially in Pittsburgh, because I've lived there for most of my time here in the States, right? You have the winter and you get these fumes coming back of the car because of the exhaust. And these exhaust fumes are, what do you call, like, stray points on the sensor, and, they kind of create noise in the data. So a lot of these challenges, right, they're already specific as well, but there are most of them, again, 80-20, right, or 90-10 problem. 90% you can generalize, 10% you have to be specific. All right, Gujon, maybe a next question for you. If I had to summarize the machine learning models we talked about for deployment on board, a gentleman is asking, would we have enough GP power on, series cars? I'm hoping they mean, production line vehicles. Are these GP capabilities going to be present by default for the vehicles coming out? Not purpose-built, or maybe purpose-built vehicles for robotaxi kind of application, but what's your sense of the compute that's going to be on the platforms?
Yeah, I think, we can easily say the mainly autonomous vehicle, autonomous driving problem is right now becoming a bottleneck on compute and the sensors, because we see very large models capable of doing very good tasks, and then you are trying to going back to the same thing, the distillation, right? And most of the automobile, like the OEMs, are aware of this now. It wasn't before, because everybody was they were not believing in this is going to be happening, and they were like, okay, we want to be save the costs. And now they see that this is capable, and they are always thinking about how much of the power, how much of the compute we can put in it. So I think all the new models are coming with the more power of the compute.
It's funny, I've seen a couple of social media or LinkedIn videos where someone had plugged in a PlayStation or an Xbox to their compute on the car, and they're playing that in the vehicle. Which you can do a whole bunch of crazy stuff once you have this, powerful GPUs in the car. But yeah, don't do that. That will void your warranty if you do it. All right, so moving on to the next one. We've got an interesting question from Asit. How do we address the problems of sudden ODD changes or anomalies that happen on road, like potholes, construction? Well, let me start by saying that especially if you're operating in an ODD like Las Vegas, this is bound to happen every single hour, because there's a whole bunch of construction, events, changes that happen. Chenji, I want you to answer to the question, but I'll just give my point of view that these are all dynamic changes to the ODD, and you need to design your system in a way that can handle these anomalies gracefully, like a human driver. And in case where you can't handle them, you should have a risk maneuvering system where you again, pull over, or take a response which is very, again, natural, not sudden, not abrupt, because that's what leads to accidents. Chenji, anything you want to add to that or supplement?
Good question. So it happens all the time to us, right? So like say there's certain changes on the road, or if the map, the road structure changes, or there's construction zone, or they're just road events happening. So one way to handle is most of I think the commercialized road taxi system, they have very good remote kind of assistance system. Remote assistance system. Yeah, it can help you whenever that condition is being detected. It will trigger, and then the human operator will guide kind of the vehicle through these complex scenarios. In nominal cases, when it's safe. How to detect those? Yeah, I've been worked on these kind of detection, anomaly detection system. I work with someone closely on that in the past as well. You can actually estimate based on the scene input. You can actually look into the difficultness. You can estimate that how much that the system think it can handle from upstream all the way to downstream. And trigger this either kind of remote assistance request or some maneuvering or just pull over or emergency kind of behavior. That's one way to do it.
Makes sense. And I think, it's just, if you're able to solve for all the problems, we would have a, self-driving product out from every company right now, which I'm sure will happen, but it's a challenging thing to solve for all these cases. We'll take a last question, Guchon, for you, which is, what are some of the KPIs that you develop for measuring ML model improvements? If you can, give a couple of concrete examples, and we can, wrap up with that.
Yeah. So for the perception, we use most of the standard ones in general. That's pretty standard for, like, maybe if you guys are familiar with the detection scores, like the F1 scores. And I think the main part is how you slice and dice the data. Sometimes we generate specific metrics that is related to your task. For example, when you are having the autonomous vehicle metrics, like, does the car care if you detect some object 3 lanes on the right with the concrete barrier that you will never ever interact it? Sometimes you slice and dice the data to make sure that you are getting the most interesting, like where you can have an interaction with those cars and pedestrians or whatever objects that you are gonna interact with. On the top of that, like, again, depends on the context. For synthetic data generation, there are other methods to make sure that this is very highly realistic method. Very, very specific. I would say the very specific the tasks, but maybe going back to my previous point, for testing and validation, those are pretty mature measurements. You just add a little bit nuances to help you to understand the data better.
Got it. Okay. Perfect. So I think this wraps up our Q&A. We had a couple of questions around reference sources on synthetic data and links, like that. What we'll do is, once we post the recording of the session on LinkedIn or as an email, Preeti will take care of that. We'll attach a couple of reference links so the audience can read them, more in detail as required. But this is a wrap for us on the first session. So I really want to thank Guchon, Chenji for their time in preparing for this session, in spending an hour with us. It's been awesome, and this is, again, only a start. So again, a big thank you, Chenji, Guchon. Thank you for being here.
Thanks for having us.
Yeah, thank you all.
And before we wrap it up, so the next 2 topics we're going to have in the series, we are going to be talking about performance evaluation frameworks for autonomous systems. I personally have worked on that for a long time, so I'm hoping we'll get a very good set of panelists across the industry to join us in the month of Feb, towards the end of it. And then March is going to be about advancement in SIM for making a verifiable AI. Right at the end of the day, all of this will only work if you can prove what you're saying you're doing in a very verifiable manner. So we're going to have these 2 topics in Feb and March. Keep an eye out on LinkedIn, and our marketing team is going to send out updates But I think that's a wrap for us. Preeti, anything to wrap up?
No, I just want to thank you to both the panelists and all the attendees for this wonderful session. And we'll share the recording for those who want to refer to it, all the insights that we have got from Chengi and Gujan and Sahil. Thank you so much, team, for joining us.
Thanks all. Have a good night and good day.
All right. Bye-bye.